So in this video, we're going to talk about what's the difference between accuracy and precision, and then we're going to talk about we're going to do an example and kind of see if you actually get the concept. So starting with the definition, we say an accuracy in chemistry is how close a measured value is to its actual value. So this actual value is actually key. So how close a measurement is to its actual value. So let's say you go in the lab and let's say you have a lead block and we know that it's the actual mass of the lead block is like, let's say 9 grams. Then you would compare your measurement to the 9 grams and we say, okay, well, if you're close to 9 grams, let's say you're 8.99 or even like 9.01, we'll say you're pretty accurate. Now, precision on the other end refers to how close a series of measurements are in relation to one another. So how close a series of measurements are in relation to one another. So let's do an example. Let's say we have a known block where in the previous slide we talked about the block being at a weight of 9 grams, right? But in this case, the example that we're using, our lead block, is 10 grams. So that's the known block, that's the known measurement of a block before you actually go in the lab and perform your measurement. So that is the true value of the block. So let's say we have 3 students. We have student A, student B, and student C, and they each do 4 trials, right? So you can see student A here. Their first trial is about 10.449, 9.79, and these are in grams, right? So this G right here stands for grams. Now the average, as you can see, student A, it's about 10.13. Now look at student B. They're about 9.78, 9.82, 9.90, and 9.79, right? So their average is about 9.79. And as you can see for student C, they're about 10.03, 9.99, 9.98, 10.01. So their average is about 10.01 grams. Now, the question that I pose to you is, based on our definition, what would you classify student A as with respect to accuracy and precision? Would they be accurate and precise? Would they be inaccurate but precise? Would they be precise, right? So would they be accurate and precise, right? So that's the question I want you to answer. I want you to answer the question. So pause the video, and then we're going to talk about the answers. Now, it may behoove you to look at this in a graph format. Obviously, it's still relatively easy to do from the table, but let's look at it in terms of a graph, right? And those numbers that we spoke about above, we've actually graphed them. So student A, the number of trials is on the x-axis, and our mass is on the y-axis, right? So our mass in grams is on the y-axis, and the number of trials is on the x-axis. Now here's a true mass of the block, which is at 10 grams, haven't changed. So that is the known mass that we know prior to making our measurements. Now, as you can see, look at these numbers. Trial 1 is about 10.49. The true mass is 10. Trial 2, he way undershoots it. Trial 3, okay, trial 3 is a little bit closer to the true mass, and then trial 4, he overshoots it again. So in this case, what would you say in terms of accuracy and precision? Right? He's inaccurate, right? And we say that he would be inaccurate in this case, right? So he would be inaccurate. He would be inaccurate, right? Because he's not. He pretty much only got. He's pretty much he pretty much got close to the true block, to the true measurement of the block really only once, right? And as you can see, these numbers are all over the place. They're not in synchrony with each other. They're all over the place. But when we say inaccurate, we're comparing these measurements to the true value, and he's only hit like one, right? So only one out of the 4 trials were really actually close to the true value. So we say he is inaccurate. Now, what about precision? What do you think? Do you think he's imprecise or precise? And this would be imprecise, right? It would be precise because look at the measurement with relations to each other. This one is all the way up at 10.49. This is all the way down at 9.79. This is a little bit up from 9.79, and this is way up from 9.92. So the numbers with relations, with respect to their self, is not really close together, and so we say they're imprecise. Right? So numbers are not really close together with respect to themselves, and so we say that a number, so we say he's imprecise. Again, with precision, we're not really comparing it to the true value. We're comparing the numbers, a series of measurements, like our definition says. And these are not close with each other. Now let's look at student B. Student B is interesting. Would you say he's inaccurate or accurate? And I would say he's inaccurate. Why? Because look at our true value. The true value is 10 grams. Look at all these measurements. He's nowhere close to true value of 10 grams, right? He's nowhere close to the true value of 10 grams. So we'll say that this is inaccurate. Now, what about precision? Do you think he's imprecise or precise? And he's actually precise. So he is inaccurate but precise. So he's inaccurate but precise. Why? With precision, we're not comparing it to the true value. We're comparing the numbers relative to each other. So we're comparing a series of measurements relative to each other. So look at these numbers here. He hits the first trial about 9.78. And second trial is about 9.82, really just 0.04 up. So they're not really far off. The third trial, 9.75, so he's still within that range. And the fourth trial is about 9.80. So he's like really tethering around 9 point. You would say the average for this would maybe be 9.79. And you could see with precision, again, we're not comparing to the actual value, to the true mass of the block. We're comparing a series of measurements relative to each other. So again, all these numbers are close in proximity with themselves. So you would say that he's inaccurate. He's not hitting the true mass, but with relative, but he's precise because again the numbers are in close proximity with each other. Now let's look at student C. What would you say student C is? Do you think he's inaccurate? So this is student C. And again, x-axis represents the number of trials. Do you think he's inaccurate or accurate? And my guess would be he's actually accurate. Why would he be accurate? Well, remember, accuracy we're comparing to a true value. So we know that before going into the lab, we know that the true mass of the lead block is actually 10 grams. Now look at our measurements. The first one is in the first trial, he hits it about 10.03. Okay, so that's not really far off from the true value. The second measurement, he's about 9.99, even more closer. The third measurement, he's about 10.03 again. Still really not far off from the actual true value. And the fourth measurement, he's about 9.98, just a little bit off from the true value. And so we'll say, actually, this is actually really accurate. Now, what about precision? Do you think he's precise or imprecise? And my guess would be he's actually precise. So this student is actually accurate and precise. Why? Because look at the measurements with respect to each other. 9.98, 10.03, 9.99, 10.03. He even hits 10.03 twice, right? So we say that he is also precise because the measurements with respect to each other are really, really close. And so say this student is actually accurate and precise. So this is a student you would want in your lab, right? And it should make sense going back to our averages. As you can see, with respect to the accuracy, the known block, the mass of the known block is about, we said earlier was 10.00 grams or 10 grams. Here it's about student C's average is about 10.01, so he's like really right there. So we say he's accurate. 9.79, you would not expect him to be accurate again, looking at the average, because again, our true mass is about 10. And student A, I mean, he overshoots it by a bit, right? So again, he would be inaccurate as well. Right? I hope this video helps.